Hello and welcome to the video lectures of colloids and surfaces. So this is how I record my lectures and I upload into YouTube so that in future these lectures serve as a virtual alternative of the regular classroom lectures, and whenever you get time you can, or whenever you wish, you can refer to these lectures online and they would help you to get a ready reference material, especially when you are preparing for your course exams and other exams like GATE, NET, etc. Okay, so we plan to cover the entire materials of colloids and surfaces through this video lecture. So today is the lecture number 1. Okay, and we start with the introduction. So there will be two parts of the introduction, part 1 and part 2. So today we start with the part 1. So probably you are taking this course for the first time, and probably you have heard about the term colloids. Okay, and so usually there comes many questions. So why with colloids we are using this term surfaces? So probably you would notice that whenever colloids term is there, in many places either surface or interface term will appear, like colloids and interfaces, colloids and surfaces, etc. So question is why we are relating surface and colloids all the time. So there is one question, so we have to answer that part. So we will come to that question later on. So let's first we start with that word colloids. Okay, so this part colloid is actually coming from a Greek term. Okay, so in ancient days Greek people used to refer a material as kolla, K-O-L-L-A. Okay, so and it literally means glue. Okay, and from that term kolla, this colloid term got developed. Now interestingly, this glue later found out that it is actually a colloidal material. Okay, so I will tell you later what was that glue actually, and what was this composition, and why it is justified to call that glue as a colloidal material. So we have some distance to go and then we will understand. Okay, so that's the origin of the term cola. So now the thing is, what do we, or how do we define the colloids? Okay, so the colloids is actually you can call it a state, okay, or a special phase of materials, or we can call substances. Okay, so these materials maybe some particles, okay, maybe some molecules, big macromolecules, etc. Okay, so now the thing is, in colloids, whenever we call it's a state and phase, that means usually there is more than one phase in a colloidal materials. Okay, so as we go along it would be a bit more clearer to you. So the thing is, whenever we talk about colloids and whenever we talk about state or phase, if there are more than one phases, then we can tell that these phases are separated by some boundaries, or we can also call it phase boundaries. Okay, now this phase boundary is interconnected or interlinked with the term It could be, we can call it, it is either interface or we can call it a surface. But this is not the sole reason that we actually connect the word surface with colloid. So there is much more strong scientific reason. But for our understanding, we can tell that whenever there exists a colloidal phase, so it is most likely there would be phase boundaries, and those phase boundaries would be related to or would be called as either interface or surface. Now the question is, are the both terms interface and surface the same, or there are differences? Yes, there is a subtle difference, and we will tell you later that in which case we call a phase boundary as an interface, and in which case we call a phase boundary as surface. So we will come to that part later. Anyway, coming to that, so whenever we call colloids as a special state or phase of some materials or substances, so it is also related with a kind of size range. So these materials or substances has to fall within certain size range. Okay, then only it is likely to form a colloidal phase, or we can also call it a colloidal system. Okay, the same thing. So the question is, so what kind of size range we can talk about when we relate to the colloidal materials or colloidal phase, or colloidal state or colloidal system. Okay, so it is very important to know the size range of these materials and substances. The question is, are all materials, like even the bulk materials or single molecule, can form a colloidal state? So that we are going to find out. So we begin with a comparative scale in our mind. Okay, comparative scale of understanding of the size ranges of different materials. Since we are chemists, so we will start from the molecules and we'll go towards the bulk end. Okay, so what I'm going to do is I'm going to clear the blackboard and I'm going to draw some diagrams, and I want to illustrate that how different things are interrelated or compare with each other with respect to size, and exactly at what size range uh, means the colloidal materials belong to exactly what kind of size range that we are going to find it out. Okay, so let's do it. So here I have drawn a comparative scale. We have started from picometer, 10 negative minus 12 meter, and we are increasing in this way up to here. So this is 10 negative 3 meter, that means millimeter. So this should be visible to us in naked eye. Okay, and this scale is now graduated with an approximate equal demarcation. So each having a length of some like a hundredth of a meter. Okay, so in this scale, now can you tell me where what would be the range of the visible wavelength? Okay, so that means the visible light having wavelength span between, say, 400 nanometer to 750 800 nanometer, so it would fall right about here. Okay, so few hundred to almost close to 8,000, or so that part we can refer as the visible light. Okay, so I just write visible here, visible light. Okay, so now let's start to demarcate the areas of the molecules. Okay, So how do we do that? So this region 10 to the power minus 11 meter or 10 picometer, this is basically where the atomic sizes are clustered. Okay, it falls below the angstrom and falls above the picometer region. So therefore, if we talk about the molecules, mean at least it should take 2 atoms to make a molecule. So our molecular size range should start from right over here, and ordinary small molecules fall much below nanometer. So we can take about this thing, this space, and we demark it as the molecules. Okay, so this is where our small and ordinary molecules, the size ranges fall. All right, good. So now the thing is, there are like the macromolecules. Okay, so macromolecules means this is the assembly of smaller molecules into big molecules. So like supramolecule or a big polymer and design self-assembly, those comes under the domain of the macromolecules. So therefore, the size range of the macromolecule obviously start from where this molecular range end, and it go up to here. Okay, so we can call this size range as macromolecules. Okay, so now you see that these macromolecules still fall well below the range of the visible wavelength of the visible light. Okay, so the next question is that we have some virus and bacteria. Okay, and so what could be the typical size ranges of these virus and bacteria? So with that, so many talks about the virus around us, so now probably we have realized that virus actually their size range starts from the smallest would be the few nanometers, and at the most they can go to few hundreds of nanometers. So this size range we can give it to the virus. Okay, all right, so now you see the virus, the size range actually gets pretty close to the macromolecules. So now as I have told you, that's the size range of bacteria. So can you guess? So obviously these bacterias are actually greater, the size of the bacteria is usually greater than the virus. So the virus, okay, the bacteria, the size of the bacteria would fall between here to somewhere around here. Okay, so we'll come back to this. Okay, so sorry about the interruption. So the bacteria usually their average size is larger than virus, and they span between few hundreds of nanometer on the higher side up to more than 10 nanometers, sometimes 50 10 micrometers, and sometimes 40-50 micrometers, sometimes even larger, but on an average we can take this size range. Okay, and this point here, it is a micron, so 10 raised to the power minus 6 meter means 1 micron. Okay, so the next is what about the nanomaterials? So we heard about we hear a lot about nanomaterials. So in which size range we can typically place them? So obviously it should start from few nanometers. So here is the nanometer region. So few nanometers means we can start it from here, and it's at least it's one of the dimensions should be close to or less than 100 nanometer, means here. And on an average means if we talk about the total dimension, So we can take the nanomaterials up to few hundreds, so like there we can take. Okay, so this part we can dedicate it to some nanomaterials. Okay, so interestingly, you see the size range of nanomaterials, it overlaps with the macromolecules and with the virus. Okay, and to some extent to some bacteria, some smaller bacteria. Okay, and then there is another naturally occurring stuff though, which is important uh, for our colloids part. So this is the winter time now, so mostly in the morning, if you go outside, sometimes you would see what, if the weather is not clear, when the sunlight is not coming, you see that there is fog outside. So now fog is some suspended particulates in the air, and those particulates have a size range. So typically, so the fog particle size range starts from few hundreds of nanometers to more than uh, like few tens of micrometers. So that part we can actually call fog. Okay, so it has a typically large size range, and towards the higher part means that from tens of nanometer, sorry, tens of microns, from 1 micron to few tens of microns, so that area is occupied by another thing is called mist. Okay, so there is a slight difference between mist and fog, but we may come to that point later. But fog, mist, whatever it is, you see they have size range pretty close matching to the bacteria. Okay, good. So now with all these things, so lastly, the only thing left to demark is the colloidal materials. So what should be the size range of the colloidal materials or colloidal particles that you can talk about? Okay. So from here, so now we are going to demarcate our colloidal materials. So the colloidal materials typically it may start with if this is the nanometer region. Okay, so it may start with the few nanometers, so its starting point could be probably would be the almost same with the nanomaterials. Okay, but for the sake of debate, we start with the just the nanometer demarcation itself. It starts from there and it goes up to, since this fog and mist I told you it belongs to the colloidal phase, so we can go up to exactly that part, and this entire size range is we dedicated it to colloids or colloidal phase, means the particles or materials that constitute the colloidal phase should fall from the size range from few nanometers to few microns. So its actual size range we can talk about that this could be like almost 5 micrometer to, you can go up to 1 nanometer or few nanometer. Okay, so you see this is a huge size range, means it's covering a great deal of many different size zones. Okay, so it overlaps with nanomaterials, with macromolecule, with virus, with bacteria. Okay, and it includes the mist and fog because these two is actually a class of colloids. So what it excludes typically is the small molecules. Okay, single molecules, but apart from that, whatever you can frame means naturally occurring or man-made, whatever, because virus, bacteria are naturally occurring, not man-made, and nanomaterials, macromolecules, those are man-made, and they fall under these size ranges. And of course, it most importantly, the visible light, the range of the visible light also falls within the size range of this entire colloidal material. Okay, so from this size range, so one thing is very clear to us, that colloidal particles are basically nanoparticles or submicron or microparticles. Okay, so we can also tell them that this is microparticles or nanoparticles. Okay, and the particles which are much bigger than nanoparticles, but not we cannot call as the microparticles yet, we can also call it submicron sized particles. Okay, or we can call it submicron particles. So those entities would definitely have the capability to form a colloidal phase. Okay, so after going through this size range, so from now on I expect that this comparative size chart should be installed in your brain. So whenever you close your eyes, you should be able to visualize that how these different particles and entities they compare with each other in terms of their average sizes or the size range. Okay, so now today what we are going to do, we come back to the colloidal phase once again to see that from our childhood, whenever we heard the term colloids, so we used the term colloids, what kind of visuals or what kind of concept that used to come to our memory. Okay, so let's check that out. Okay, so now I'm going to talk about the concept of the colloids, how it came to us as an early memory when we were children. Okay, so let's start with some simple things. So, for example, we have water in a beaker, and if we put some sand over here, okay, and if we put some sand into the water and then I try to stir it well, so after a while we will see that there will be some suspended particles of sand. Okay, and we call them suspended particle, and this suspended particle will not stay in that water forever. So after certain time, if we stop the stirring it, the particle would settle down at the bottom. Okay, so we call it settled. But before it gets settled down over here, this part, okay, we call it as a suspension. Means the time duration when those particles stay within the water defying gravity but not settled down yet, we call it a suspension. Okay, and after it gets settled down, we completely get it as a phase separated material, and every time we are able to see those small particles, and also after it gets settled down we can also clearly see those particles as an agglomerated phase. Okay, so this part is called a pure suspension. So this kind of suspension is nothing but a mixture. Okay, and we are all very familiar of it from our childhood. Now imagine the second thing, that we have a beaker of water, okay, and we have added some sugar particles, and we keep stirring it. So once we stir, we will see that the water becomes very clear, okay, and we do not see any sugar particles either being suspended or being settled down. So this forms a solution. Okay, so this is a suspension mixture, and this is a complete pure or true solution. So this true solution has two definite we can observe two properties, or there are two traits of this. Number one, that the solute particles, they never settle down. Okay, so number one, never settles, means the solute particle. And number two, the solute particles are not visible. Okay, so unlike the sand particles over here that we can see it, so these particles are not visible. Okay, and if you examine the solution by any means, by a microscope or something, you won't be able to see the solute particles. Okay, or you can take a visual record of this thing. So now we have discussed two extreme ends. Okay, so the two extreme ends are, one part is called the suspension and another part is called the solution. So we can write like that. So here we have something called suspension, and here I have something called a solution. So here, with respect to these two extreme ends, now we are going to place, there is something in between of these two, and that we call a colloidal suspension. So remember, this colloidal suspension is neither is an ordinary suspension or mixture, this is not as a simple pure solution. This is somewhat in between these two. So what is a colloidal suspension though? So we can use that word suspension with the colloid, okay, or simply we can call it as colloid or a colloidal phase. Okay. So the properties, that is, so if we have a colloidal suspension or colloid, so number two, the particle would never settle. Okay, that is the same thing as the solution. So number two, the particles, means the colloidal particles, are actually can be visible but usually not by naked eye. Okay, so that means it could be visible using some microscope. So what kind of microscope? Either it could be some optical microscope or an electron microscope or a special type of microscope. I don't know whether you have heard about it. It's called an ultra microscope. Okay, so in this this course we would talk about this optical microscope and electron microscope and ultra microscope, because since we are talking about colloids, we have to talk about their characterizations. So this part will come automatically. So we save these topics for other lecture days, where we will discuss with much more details. So therefore, whenever we talk about this colloidal suspension, as our very our conventional understanding, okay, so then we talk about two things. Obviously, whenever we place this discussion in reference to suspension and solution, that means we have already assumed that there are two different phases. What are the two different phases? So that is, here we are talking about usually water, okay, and inside water we have very small little tiny particles. Those are known as the colloidal particles actually, and those particles must be falling in the size range between 5 micron to say 1 nanometer. Okay, so that means there are two phases. So now we talk about phases. So what are the phases? So one is water, okay? So we can write it here. So the water acts as dispersion medium, and we can also call it a dispersion phase. And then there is some solid particles, because we are assuming that we are adding some solid particles in with respect to our reference as a suspension and pure solution. So those solid particles are called as a dispersed medium, or sometimes we call it dispersed phase. Okay, so together it forms a colloidal phase also, or colloidal system or colloidal suspension. So that means a colloidal system or colloidal phase would consist of two different types of mediums or two different types of phases. Also we can call it phase. So what are that? So one is called the dispersion medium or dispersion phase, and another is called the dispersed medium or dispersed phase. That means the thing that is getting dispersed into something, a bulk amount. Okay, so here these particles, whatever, those are taken in a very limited amount, means the dispersed phase or dispersed medium, and in contrast the dispersion medium, that is present in the bulk quantity. Okay, so the thing is that we are now getting some ideas that as I have already told you, that in a colloidal phase there are different phase boundaries. Okay, so in colloidal phase there exists phase boundaries. So now it starts to get clearer to us. Those phase boundary would actually define the demarcation between the two mediums. Okay, phase boundary between the dispersed and the dispersion medium. Okay. So we will have a phase boundary. For example, if we talk about a little like a macroscopic picture, okay, so we have this dispersion medium and we have this particle. So maybe this particle is a solid particle and the bulk is say water. So the dispersion medium and the dispersed, so this is the dispersed medium. So there is a phase boundary. So there exists a phase boundary. Okay, so this phase boundary separates the dispersed medium from the dispersion medium, and it is always present whenever we talk about a colloidal phase or a colloidal system. So now in the next lecture I will talk about that how this phase boundary can be differentiated into whether we call it a surface or whether we call it an interface. So we will talk about that later, and also in the next lecture we will try to learn a classification of the colloidal system based on the two mediums, that is the dispersed medium and the dispersion medium. Okay, so remember here specifically the case that we have discussed, we have taken the dispersion medium as liquid water and the dispersed medium as a solid, means some particles. Okay, so but this is only one type of combination. Remember, the dispersion medium can be liquid, solid and gas, and the dispersed medium also, apart from being solid, it can also be gas and liquid. So if we take the all combinations, then there are 9 possibilities, there are 9 combinations of dispersed and dispersion medium, and each of them would constitute a colloidal phase. Okay, so this much is enough for today's introductory lecture part 1. So in the next lecture we will finish the introduction as the part 2. So I will refer that recommended textbooks later. So till then you continue seeing these video lectures, so you can understand that this course is a little bit descriptive, so you need these online video lectures to follow along with studying your prescribed textbook. Okay, So I will see you in the next lecture. Till then, goodbye, stay safe and take care. Thank you.